Okay, on this question, it says the data in the table below shows the average time spent on the phone daily and the weight in pounds of 8 different women chosen randomly. Perform a hypothesis test at the 0.05 level to discover if there's a linear correlation between average time spent on the phone and weight. So that's weird. I mean, I wouldn't think there would be, right? Just the average amount of time somebody spends on the phone is connected to their weight. I don't know. Maybe. I doubt it, right? Maybe if you're on the phone all the time, you're never exercising. I don't know. But some people, I don't know. I don't know if there's any. But anyway, that's what we're trying to figure out. So how do you, I know it's hard on these problems as you read them, you go, well, how do you know there's so many different tests? How do you know what we're supposed to do? Well, there's a key word right here, linear correlation. Remember, the hypothesis test or claim is always the most important part of the question. It says, do a test to see if there's a linear correlation. So let's go to the notes. And here I am on the notes, exam 4 notes. It's number 6, testing linear correlation. So what do? Put the data in L1, L2, go to linear regression t-test. So we go, okay. So L1's here, L2's here. And then we go to stat, over to test, down to F, which is linear regression t-test. And when you do, I got to first put the numbers in L1 and L2. Okay, and then I'll go to the stat, integration t-test, which is F. And so when you do, you'll get X list, cell 1, Y list, that's L2, frequency was 1. And then we get the B and P thing, which, yeah, what do we do here? It doesn't actually matter. You can, well, actually, you need to choose not equal to 0. So, do a little better job there. Choose not equal to 0 because why is that? What are we actually doing? Well, we're trying to find out if the slope is not equal to 0 or is equal to 0. All right, and let me see, where does it say there? Integration t-test. Yeah, all right, so. All right, so we're choosing that. So yeah, so if in doubt, you choose not equal to 0 on these. Okay, and then it's gonna, and then we go, and then we just go calculate. Hit enter. And then we get a p-value. So I'm getting a p-value. It's 0.0034. I rounded it. It was 338. So I rounded it. Like that. Okay. So now, so we choose not equal to 0. That is important that we choose not equal to 0. And the reason is, now you might wonder, well, why? What is that, Mr. Aaron? How do you know? What are you doing there? That's the slope. You're testing the slope. And you're saying the slope is not 0, meaning if the slope is not 0, there's a linear connection. We're saying, is there or is there not a linear relationship here, a linear connection? So you should get P equals 0.0034. Now, what does that mean? And that P value is, where's my alpha? Let me grab my alpha level. Do the cell right here, 0.05. So alpha is like always 0.05. So ours is certainly less, right? If you're not sure, line up the decimals, 0034, and then just fill in the same number. So 5, 5 is way higher. So our p-value is less. So it tells you exactly what that means right now. It says, if the, I'm still on number 6, if the p-value is less than this level, then there is strong evidence that the two variables X and Y have a linear relationship. strong evidence of a linear relationship. Okay. So, strong evidence, linear relationship. Says it right there. So, significant evidence, yeah. Insignificant, no. Significant, yeah. Insignificant, no. Okay, it's one of those two: significant, strong evidence, significant. To conclude that the time on the phone and the weight are linear correlated? Yeah, strong evidence of a linear relation. That's right. The other one says, wait. The time on the phone and weight. Oh, I didn't read the rest of it. Therefore, the regression line is useful or is not valid. Oh, wait, whoops. No, not valid. That's wrong. Is useful. The regression line is useful. Where does it say that? Right here. So we can use the linear regression equation. Can use, that means it's useful. The other one, if the p-value is greater, says it's invalid to use the linear regression. See the difference? In our case, the p was less, which means we can use the linear regression equation. We can use it. If the p-value is greater than the alpha, then it's invalid to use it. So in our case, it is useful. So that's tricky. So a couple of things that can trick you on that one. Make sure you're doing not equal to 0, because it didn't say greater or less anywhere else. We're just finding out if the slope is not equal to 0, meaning if it's linear or not linear. And then read the notes. They'll tell you what it means. The line is useful. There we go.